Hi, in this video, contents related to analysis of flight logs will be shared. Flight logs are records kept by the UAV's flight control computer or flight control board, containing all data about the UAV's time in the air. These logs provide detailed data about the drone's performance and behavior during flight. They record various data such as position, speed, altitude, battery level, pitch, roll, yaw, and control inputs. When analyzed, these logs offer important insights into the UAV's performance, enabling the optimizing of the flights, early detection of faults, and enhancement of flight safety. Accurate recording of flight duration, takeoff and landing times, and flight route GPS coordinates supports the tracking and analysis of operations. Flight logs are crucial for troubleshooting, optimizing performance, conducting preventive maintenance, and meeting compliance requirements. They also include power system data such as battery voltage and current, power consumption, and motor RPM. These data should be regularly monitored by analyzed to ensure the UAV operates safely and efficiently. In addition to open source analysis tools, drone manufacturers also produce specialized software for their drones. Manufacturer-specific software includes DJI Assistant 2, Util Explorer, and Unique Data Pilot, which are used for spatial analysis and maintenance procedures provided by the manufacturer. Open source analysis tools also play a significant role in the log review process. Mission Planner for RD-Pilot's logs, PX4 Flight Reviewer for PX4 logs, and MAV Explorer for general analysis are the main programs used by technicians. The first basic step in flight log analysis is the log acquisition process. Logs are downloaded from the drone or associated application, and a backup of the original file is made. Then an initial review is conducted by checking the flight duration and basic parameters. Any obvious anomalies or error message should be evaluated. During the flight route analysis phase, GPS data plotted on the map, and unexpected deviations, GPS errors, or route deviations are reviewed. Next, altitude check and airspeed are analyzed to track anomalies such as altitude change or airspeed fluctuations. In the status analysis, graphs of pitch, roll, and yaw are created, and excessive oscillation or unusual movements are checked. In the power system analysis, battery voltage and current graphs are plotted and examine sudden voltage drops or abnormal current increases. In motor and ESC analysis, motor RPM graphs are plotted, and disappearances or sudden change between motors are tracked. In radio control analysis, signal strength and control inputs are analyzed. Signal interrupts and unexpected control inputs are monitored. Finally, sensor data and flight event errors are examined. GPS, barometric, and altitude data are checked by ensure they are within the expected values. Compass validation is performed. At this stage, all system events are previewed, and warnings and errors are correlated with other flight data or for detailed evaluation. Vibration analysis is one of the advanced analysis techniques for flight logs. When analyzing accelerometer data, dominant frequencies values should be determined using fast Fourier transform and compared with known drone resonance frequency values to identify potential issues. PID tuning analysis is also an important step. In PID analysis, desired and actual states should be grabbed, deviation and limit values examined, and oscillation indicating poor calibration should be noted. In power efficiency analysis, power efficiency should be evaluated by calculating power consumption for a specific distance, and comparing consumption under different flight conditions to identify factors affecting power efficiency. Finally, for anomaly detection, etc., deviation from normal values, current data should be compared with previously recorded trouble-free flight data. Statistical methods should be used to identify inconsistent value and investigate situations showing deviations from normal. For an effective maintenance and analysis process, it is important to establish a standardized reporting format. This format should include a summary of flight information, key findings and observations, detailed analysis results, and action recommendations. Adding relevant graphs and charts to reports for visual representation makes the information more understandable. Clearly specifying required maintenance and calibration procedures and prioritizing issues by importance is critical for an effective problem-solving process. Establishing a database of flight logs and analysis reports will improve maintenance and the analysis process in the long term. A standard procedure should be established for flight log analysis, and flight logs should be regularly reviewed after each flight. This analysis should consider flight conditions such as weather and mission type and account for recent maintenance or change to the drone. Keeping up with technological advancements and being informed about new analysis techniques and tools is essential, as is ensuring the secure storage and backup of all flight logs. Today, some integrated software solutions provide comprehensive data analysis from flight logs and seamlessly convert raw telemetry data into useful analysis. Advanced visualization tools like FlightNow, Tower, Mission Planner, and Drone Deploy provide graphical representation of flight performance, sensor readings, and environmental conditions. These platforms facilitated the preparation of reports that automatically compile detailed technical summaries and identify critical metrics such as battery consumption, GPS tracking, altitude change, and mechanical stress indicators. Data interpretation in the drone operations involves a multi-phased approach to derive meaningful insights from complex data sets. Technicians should specialize in the advanced pattern recognition techniques that allow them to identify fine correlations and significant variation in the collected information. Performance metrics analysis is critical, enabling operators to evaluate drone efficiency, mission success rates, and operational parameters through comprehensive statistical assessment. Anomaly detection plays a crucial role identifying unexpected issues that may indicate equipment failure, environmental challenges, or potential safety risks. Trend analysis helps professionals understand data patterns, aiding in the identification of the predictive needs for future mission planning and equipment maintenance. Drone technicians should be capable making robust, holistic interpretation by effectively cross-referencing multiple data sources, enhancing decision-making process, improving maintenance needs, and ensuring maximum mission reliability in maintenance environments. Preventive maintenance through flight logs analysis is a critical method for ensuring optimal system reliability and performance for drone technicians and operators. By meticulously examining operational flight logs, technicians can identify component wear issues, degradation in system performance, and potential failure points before they escalate into crucial critical failures. Advanced flight log analysis techniques enable the development of sophisticated failure prediction models that allow for preventive maintenance interventions using early warning signs of potential issues. This information helps operators create dynamic data-driven maintenance schedules that optimize equipment lifespan, reduce unexpected downtime, and minimize repair costs. Through comprehensive flight log monitoring and intelligent pattern recognition, drone maintenance experts can transition from reactive repair strategies to predictive approach that enhance overall system resilience, flight safety, and operational efficiency across various environmental and operational conditions. Performance improved in drone operation is multifaceted process requiring comprehensive analysis in several critical areas. Technicians should holistically evaluate flight efficiency by examining factors such as high aerodynamic design, propulsion system performance, and energy consumption patterns. For better usage improvements, focusing on intelligence power management strategies, charging protocols, and better life cycle assessment is important. Route planning improvements leverage advanced algorithms and real-time data processing to maximize flight distance, minimize energy consumption, and enhance mission effectiveness. Payload impact assessment carefully evaluates the effects of weight distribution, and payload configuration on drone stability and flight characteristics. Additionally, environmental factors play a crucial role, requiring operators to account for atmospheric conditions, temperature variations, wind dynamics, and potential electromagnetic interference that can significantly impact drone performance and operational reliability. In this section, we covered flight logs and their analysis in UAVs. I hope the contents have been helpful. See you in next content. Goodbye.